Hi guys, welcome to the I Do 7, 8 and 9 programs. Yes, you've guessed it. We are going to program a game. A game I'm addicted to. A game that's actually the reason why you have to wait for your papers to be marked. I'm sorry, but I'm also sorry for introducing you to this game. What's the use if you get distinctions for your subjects but you do not know how to play the Watersort puzzle? Keep it on your phone for a few days and then delete it, otherwise your marks will disappear. Okay, first of all, we are going to do 3 practicals on Watersort and we are going to guide you, and the aim is that you are going to program this game. Isn't that amazing? Think about it. At the end, you are going to program the game. Just to manage your expectations, we are not going to do it with a graphical user interface, but that does not stop the fun. And of course, in the 4th practical, which is not given to you, that's actually your holiday work. You can translate this into Java's graphical user interface or even play with the game engine Unity. Okay, let's start off. Have you played this game before? Have you seen it? If not, it's not a problem. Let me show you how we play it. Nou, pause ek gaan nie. First of all, you have to install the Watersort puzzle game from your app store. On your phone, on your tablet, on your computer. It is in the Apple App Store, it is in the Android App Store, and this one comes from the Microsoft Store. You can use any one, they are all almost the same. You know now how mine appears, try to find the same one. The aim of the game is to sort the colors in the little bottles, and you have to end up with 3 sorted bottles, and in this case, and 2 empty bottles. Now the graphics is amazing, but that is your 4th practical. So let's try to solve this. We look how cool is that. We can put water in another bottle. Now the aim of the game is to add colors on colors, the rules. Now you know what I mean with rules. Think about special cases, think about programming algorithms while you do this. Can I pour red on blue? No, I can't, but I can pour blue on blue. I touch my screen and then I pour it. Okay, this is an easy one. I'm at level 457 on my phone, and believe me, it's taking a little bit of more thinking power to do this. Let's go for that bottle for red. You see, I'm extremely clever. I can do this easily. Okay, now red is there. Can you tell me what to do next? Think about it. Yes, you are right. Put that one there. That one there. Okay, now my yellow is sorted. I'm going to put blue there. And I'm going to put red there. And blue there. And my game is solved. Now have a look at my solved game. What makes my game solved? When is a game solved? Did you figure out when this puzzle is sorted? When the bottle is filled with one color. But it has to be filled. A half a bottle is not a solved puzzle. So it's more to check than to check only if there's only one color in that bottle. But why are we doing it in this course? And now it's time to think about our theory. Do you know what study unit 5 is about? It's about stacks and queues. Do you know what a stack is? Now, I'm not going to, in this video, cover the study material of study unit 5. There are nice videos for you to watch. I'm just going to get your mind thinking. A stack is a specific kind of list. You can implement it with either an array or a linked list. A stack has a very unique property. You can only add and remove elements at one end of a list. So if I draw a stack has what we call a top. And I can push, listen to the word, I can push items into the stack. So let's fill that bottom. We push a blue. What should I push next? You've guessed it, yellow. Let's push another one. I think it looks pink to me, but let's say the guys agree with me that that's red. And let's push another blue one. So we are going to remember the term push. And if I want to remove something from a stack, the top one is always removed first, because a stack is a LIFO structure. Do you know what LIFO stands for? Last in. Yes, you are right. Last in, first out. Now, if push is adding things to the stack, what do you think is getting stuff out of this stack? You've got it, pop. So if I pop something once, only the top element is popped. Pop means remove from the stack. And then there's another one which is quite cool, which we only use for this practical. It says peek. What is peek? Peek means pop without removing. Just peek at it and do not remove it. Leave it there. Okay, so now you know what a stack is. You can give yourself a tick here. You know what the Watersort puzzle is. Can you see that it's full of stacks? Can you see that if I move this element there, I pop it from here and I push it here? Okay, and now the final part of this video is I want to show you the end result of the game we've programmed. So this is where you are going to end up after your third assignment. Stop and stare. Do you see 5 bottles? Do you see the colors in the bottle? Which colors are in bottle 0? I see green, red, blue and green. Do you see it as well? In bottle 1, there's only one stripe. And what's the color of that stripe? Blue. And in bottle 2, yes, bottle 2 has a little bit of red ink. Can you see that? Bottle 3 has 3 items in it, green, red and blue, and bottle 4 has red, green and blue in. Can you now see why we use the character class? Now, different from the game I just showed you, we are not starting with 2 empty bottles, but we are starting with a lot of empty slots. Can you see that there are 4 slots per bottle? So if we have 5 bottles numbered from 0 to 4, we have 4 times 5 equals 20 slots. So if we start off and we want to say 2 empty bottles, then we are going to have 12 slots. Okay, so you will have 8 empty slots. Now I'm the user, now I'm playing. Now how did I create that screen? That is your practical 2. There are 2 strategies and I use strategy number 2 for this one. Let me just browse up. You can see the compiler worked very hard to build up to this problem, but this is all strategy number 2. Strategy number 1 is easier, but you will notice in the question paper and the video later that it has disadvantages. Now I'm going to start playing. I'm now the user, the player, but I can't push my finger on the screen. It's, sorry, not a graphical user interface. So now I'm going to ask the user, enter source bottle number, and what are we going to do? First of all, let's focus on playing this game. I think I should put blue in bottle 1. Do you agree with me? So I'm going to say my target, my source bottle is bottle 3, and I'm going to say my target bottle is bottle 1. Now have a look. Was this successful? That blue there has disappeared and it's there. Okay, so my program is working. Now I can, bottle 4 has something I can do. So let's enter bottle 4 and I'm going to put that in bottle 1. Okay, just one little thing. I should not spill ink. Does this sound like a special case to you? It should. Let's spill ink. Let's say we are taking bottle 4, which is green, that's valid, and we put that stuff in bottle 1. And now bottle 1, oh, I've tested another one here. Bottle 1 is green. I put that on blue, and then my compiler told me color is not matching. But let's try that other special case as well. Let's put green bottle 4 in bottle 0, and then it tells me my target is full. So can you see the special cases? Okay, now before it runs off my screen, I'm quickly going to put something from bottle 3 in bottle 2 because that's a valid move. Bottle 3 in bottle 2, and there I go. I'm not going to give you all the special cases, but what should happen if I type in a 7? Think about that. Okay, let's just continue until our problem is solved here. I think I'm going to go for green in bottle 3. Do you agree? So let's put from bottle 0 to bottle 3. Okay, it's working. Let's put, I think we can put bottle 4 to bottle 3. See if you agree with me. That's why you have to play the GUI game all the time, to get the hang of playing the game before you try doing it without the user interface. If I go from bottle 4 to bottle 2, can you see how my progress is? I'm very good at this, much better than I am at programming. Go for bottle 1, red, I'm putting from 0 into 2. And I'm only stuck with bottle 0, but think what should happen now. Think carefully what should happen now. From 0 to bottle 3. A very, very boring message. But luckily I have, if you can hear it, I have loud weather behind me. There's huge thunderstorms congratulating me on my solved puzzle. And with that, we are going to pause and stop this video, and you can watch later the first version of the assignment. Hi guys, it's now to start to work seriously on our Watersort puzzle. We are doing the practical in 3 parts, ending with the program you saw demonstrated in the introduction. You can of course do a 4th part to make it a graphical user interface, but that's not part of our syllabus. Our syllabus is on data structures and algorithms, and the stack is a data structure. Okay, now 3 parts I said. Part 1 is kind of boring and in a way removed from the game. We are going to do preparation to be able to write the game later on. We are going to use the array class. Now I want you to first stop and go and look at the study unit 5 session 2 video. It's because in session 2 in study unit 5 there's a video on using the myArrayList class to create a stack as myArrayList class. And that is what we are going to do in part 1. We are going to extend both those classes with some functionality to be able to write the programs later. So you need to understand that session 2. And of course, you need to be able to play the game, otherwise, you won't know what we are doing. Okay, so let's focus first on the myArrayList class additions. Now, the idea is the most important thing to understand, and that is we have to figure out when the game is finished. And what I have added here is have a look at this picture here. The game is done if all the colors in a bottle are the same. But not only that, this game is not done, although all the colors in each bottle are the same. And if the bottles are filled to capacity, then the game is done. Now, we are going to add methods. We are going to check uniform. Uniform means all the items are the same. And we are going to do get size to see how many items are there. Now, I'm going to ask you to use the specific variable names and everything we provide, because we are going to give you the suggested answer of this part 1, and you can continue from our program, but it will be so much easier for you to work further if you use the same variables and the same names that we are using. You might wonder if you have to follow the things we do you have to do it in this order? Do you have to do it this way? And the answer is, I'm talking now to the very top students, and the answer is unfortunately yes, because I want to make sure that we achieve all the learning outcomes we want to achieve. Our main learning outcome is not to write the game. Our main learning outcome is to understand stacks, and what you have to do are steps to understand stacks, and but we are also solving this problem and creating the game. Okay, so we have to add two methods to the myArrayList class, and those two methods is first a method returning a boolean check uniform. Now we are again in like study unit 3. You have to write down the special cases, the algorithm. Can you develop a method for the class myArrayList which checks if all the elements of that array list has the same value? What would be your special cases? What would be your general cases? It's actually a very easy method to write. Okay, that's the one thing you have to do. The other thing you have to do is you must make sure there's a accessor method. Remember accessors and mutators? Just make sure there's one for get size in the class you have. Okay, so the first, if I go back, the first set of modifications is for the myArrayList class. Now we are going to do modifications for the stackers myArrayList class. Now you know that the stack is a restricted structure. You cannot do anything to a stack, but we are going to cheat a little bit. The first thing we are going to do is not cheating at all. In the videos on the study unit, I refer to peek, but we do mostly pop and push. And you know that in order to write this game, we need a peek. So you are going to add a peek. But remember, a peek is almost exactly like a pop. You are just not removing the element. So to create a peek is just copy and paste, and voila, there you go. And now we are going to do two non-stack-like operators. We are also going to add to that class, but that's just to get this game up and running. And we are not changing the axis. We are just getting some characteristics of our stack. We are going to add get stack size and check stack uniform. the two methods we just added to the is my array list class. We are going to add now to the stack class. Okay, and we can for both of them we do exactly the same thing. We call the appropriate method from the myArrayList class. So in the getStackSize we call the getSize, and in the getStackUniform class we call the checkUniform method from the myArray class. You just added them there. Okay, how do you do that? Easy peasy. We did it exactly the same thing with the toString. So first understand the toString method, and then you do the same for the other two. Okay, and then after you've done that, you have to write a test program. Now the test program is actually the game itself. So you call it Watersort, and we are going to do a few things with the test program. We are first going to create a single bottle. So focus on a single bottle. That bottle will be first empty initially. So what is a single bottle? It is one instance, one object of the stack as array list class. And what objects are we going to push in it? You guessed it. We are going to use the wrapper class character. Up to now we use the wrapper class integer, but we are going to play now with the wrapper class character. Makes it much easier to play with these characters for the colors than it is to play with integers. So we are also going to put some ink in the bottle. How do you get ink in the bottle? You push a character. So you have to write a little bit of code in your test program to test getStackSize and checkStackUniform methods. So you have to push characters and then call getStackUniform and call getStackSize to make sure they work. Think about testing the special cases as well. You should know by now that these things are not difficult. I can obviously give you little steps and give you more information, but that's not what I want to do. I want you to go and battle with it. So think about carefully what you are trying to do. You create one stack, you add it with colors, and you add colors in it. How do I add colors? I push variables for red or blue or whatever. So you have to create 3 objects of the character class. Call them red, green, and blue just to make comparing your code with mine much easier later. And you have to check that you do not spill. Okay, only if you've succeeded with that, you continue with your test program. And can you see there's one bottle we are working with, and now we are working with 5 bottles. Carefully think about the game. If that is one stack, there's another stack, there's another stack, there's another stack, there's another stack. We require some kind of data structure that you can have 5 objects of the same class in that data structure. Do you know what data structures are available? Isn't that cool? We can use an array. So let me draw that again. So we use an array of 5 items. Now obviously you can tell me, can I use my array list from study unit 3? The answer is yes and no. Yes, you can use it, but then you have to use accessors all the time. If you use a normal array, built-in type of array, in Java, normal Java built-in array, you can use this notation of the square brackets directly and it's easier. So let's go for a normal array. Okay, so what should your test program do? And that's what you should submit. You should create the data structure, the array of 5 bottles, and then you should add ink to it. But you have to also write a method show all, and that method's output is here at the bottom, and that is to show the current contents of the bottles. So how do you write show all? You call the toString of the stack class. But you have an array and you want to call the toString for that one, 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 the toString for that one. Can you see that the for loop for your array works well? I hope you see how this is coming together. So in your test program, you can write a method called showAll that calls the toString. It's only 3 lines of code. And then later in your main method, you can make sure that you test everything. Okay, so now that's the end of your first practical. What's next? Can you figure it out? Think about this before going on and before watching the next video. Think about the game and everything. Think about the demonstration I gave you in the introductory video. But think about it. Do not let me spoon feed you. Just get your mind around the problem before you simply look at the next video. Good luck. I wish you all the success with this practical. Congratulations. I hope you had success in part 1. If you did not, look at the suggested answer and then you can fix your program. I'm sure you will find your errors quickly and you will realize that this is not that difficult at all. Now we are going to do part 2. Now we ended up part 1 by asking you what do you think part 2 is? And part 2 is set up the problem before you start to solve it. So part 2 is more or less where I started the demonstration on the introductory video. That was after part 2 was done. A problem to be solved, like the one here at the top. Okay, now so the aim of part 2 is to set up the puzzle for the player to solve in part 3. So now you know already what's part 3 all about. And I want to tell you, this is harder than you think to get to this point. There are 2 strategies, and both of the 2 have advantages and disadvantages. You can choose any one. So I'm going to tell you the 2 strategies, and then you can select any one to implement. But both involve random numbers. So if you have not studied random numbers before in Java, it's time to go and ask your old friend Google how to use random numbers in Java and what random numbers is. Now, we are going to start our program not with the 2 empty bottles. We are just going to use enough empty slots. As I said in the introduction, if you look at carefully, there are 4 slots per bottle and there are 5 bottles. So there are actually 20 slots. So if you do work with 2 empty bottles, there are kind of 8 slots empty. And that's what we are starting with. Okay, so we are going to do with the first strategy. The first strategy is actually to start off with 5 empty bottles and then choose randomly a bottle to add 4 blue ones in. And so you add 4 blue spots. You push blue in 4 bottles randomly, 5 bottles randomly. Then you push red in 5 bottles randomly, and then you push yellow in our example, green in our program, to 5 bottles randomly. Do you understand strategy 1? Start with 5 empty bottles and push 4 times blue randomly in a bottle. Push 4 times pink randomly in a bottle or red, and push 4 times yellow randomly in a bottle. Okay, what is the advantage of this strategy? It's easy to have 2 empty bottles because you can do it randomly only with 3 bottles. The disadvantage is you end up with a puzzle. You might end up with a puzzle that's not solvable. If you play the game on the internet for a long time, I think level 30, level 40, you can tell me, I can't remember. There are more bottles with more colors. And the more bottles with more colors is, then there's 8 empty slots in relation. 8 out of 20 is 40%. Do you agree with me? Am I right? 8 out of 20 is 4 out of 10, so it's 40%. We have 40% additional spaces here. At some point, if we add bottles and colors and make the game more interesting and more difficult, we might only add with 5% empty bottles. And then this strategy might not be solvable. You might end up with a problem that's impossible to solve. And therefore, strategy 2. Strategy 2 is to start off with 3 sorted bottles and to distribute it randomly, the colors, for a fixed number of moves. The more moves you do, the more complex it is to solve the problem. Now, the difficulty is if you start moving it randomly from this one to this one, from that one to that one, from that one, you might end up not moving the bottom here. So if you just keep on moving randomly, it's very hard to actually scramble the bottom part. Now, in my program I wrote, I did strategy 2 because it was the more difficult of the two to actually do. So I ended up solving it or more or less addressing that problem by taking, okay, picture this as sorted. By taking one of the sorted bottles, one from bottle 1, one from bottle 2, one from bottle 3, to a random other bottle. And then again, one from bottle 1, one from bottle 2, one from bottle 3 to a other bottle. And if I do it enough times, I think I ended up with something like 120 moves. Then I managed to reach really the bottom of the bottles when I scramble it. The advantage is it's solvable because you are playing the game in reverse. You kind of do the reverse from what you expect the user should do. The disadvantage is to reach this bottoms. So I solved it by doing a round. One round is move one from every bottle, but it still took me more than 100 iterations. Now the computer is doing it. You can see this in the introductory video. I keep on scrolling up sometime right at the beginning of the video. I scroll through the work done by the compiler. Okay, so what should you do for your practical? You need to extend your Watersort program to implement either of these strategies, either one or two. And you should see that you're not spilling ink. So you should check something very specific when you add to a bottle. And so that's why you need to get size. And I want you to use the stack operators. So if I move something to a bottle, I watch it here, I pop it here, and I push it here. And so you need only to submit one of the two strategies. You should end up with output like in my demonstration I started with 5 scrambled bottles. Enjoy, it's lots of fun. Get strategy 1 working fine, and then you can do strategy 2. A note on the random numbers, just Google random numbers in Java, figure out how it works, and then just use it. Okay, good luck. And you really want to get this working. You know you will get the answer before you have to submit Watersort puzzle number 3, but try your hardest to solve this because you have the code for Watersort puzzle number 1, and that's the hardest part is that array of bottles. So you know now how to do that. Try really, really, really hard to do this on your own. And furthermore, you know, this is fun and this is what you are studying to do. So try to take time and enjoy this. So we created the bottles, we set up the puzzle, and think about part 3. But I'm sure you know what part 3 is about now. Good luck with part 2. Enjoy. Yes, you've guessed it. Part 3 is all about a user playing your game. A user is having fun. It's like that advertisement of licorice all sorts, don't play with your food. Now you are going to play a lot with your assignment in this practical. Okay, so it's about playing the game. We don't want to spoil your fun and to give you too much guidance. You can go in and check out that introductory video. That's what you have to create. But we want to give you a little bit of guidance. You have to write a method for your test class called solved, which receive your array list of the bottles, and you have to return a boolean for whether it is solved. Now, carefully look again at this diagram. Is this solved? Mm-mm. Because although each bottle has a uniform color, they are not full. So some of the bottles must be full, some of them empty. You can write a code. Okay, and you will need now carefully to know what is the difference between pick and pop before you can continue. You are going to have to implement the finer rules of the game, but we don't want you to give away too much. I can just tell you that the whole thing has a huge while loop. So you start off with a while loop, and that while loop is while not solved. Do you agree? And now you get the user input. I'm just going to say there, scan, check whether it's valid, and do make the move. So what we are going to do when marking it, you just give us your best effort, make sure it's working, and then in your best effort we will check on our marking scheme. Did you do this special case? Did you do this special case? Did you do this special case? Okay, before we get there, there's a special case and that you can add. It's not really a special case. What happens if I take this bottle to this bottle? How many red ones should be poured? Uh-huh. Can you see, if I pour this bottle to that bottle, only one item is poured. But if I pour this bottle to this bottle, 2 items can be poured because there are 2 adjacent elements with the same color and there's space for it. Very important, there's space there for it. So you can just keep that in mind. So Very important, do not expect the solution. We are not going to give you the solution with all the detail. You can spend in the holiday to refine it and get it to work, because no one in industry will give you the answers of your programs you're going to write. Otherwise, what's the point? So you are going to submit your best effort. Now, all about future fun. What can you do in the holiday? You can make it a GUI. Yes, it's written in Unity. You can try it out. But you can, if you just ignore the boring thing, you can see this as a button. And then you can add buttons to Java. You can make a graphical user interface in Java, or you can do it in C# or something else. But another thing that's closer to my heart is the undo function. Undo is always a stack. So a stack of operators. So of actions. So every time you do something, you add that action. Well, let's call it a move. You add that move on the stack. And if you want to undo, you pop the latest move from the stack and you do the opposite. You switch the source and the target. Think about it. It's great fun. But well, unfortunately, we can't do it because we ran out of time. So, but I want you to, in the holiday, do it actually, just to play with your game, and you will need to create a class for a move, so that you store in a different stack. You store objects of your move class, and your move class must have a source and a target, so that you can undo the move. So every time, from the beginning of the game, every time there's a valid move, you have to push that move on the stack, and then you have to pop it every time the user does an undo. You will see the game on the App Store has a limit on 5 undos. That is actually hard to do with a stack. It's better to do it with a queue, with a special kind of queue, a deck. That is a special kind of queue. But if you ignore the limit of 5, you can do it with a stack. So I think it's better to do that with a stack. So what I wanted to achieve in this little project is to tell you that you can write cool programs now. You can actually do the algorithm for this game that I play every day. I'm a bit addicted to it. And you will also notice that this game is very much the basis of other computer games. I don't know if you play the game Free Cell. If you if you haven't played it, download it. It's a card game. It's similar to solitaire, but it's actually the same idea. So many of the games that's available, computer games, has this kind of idea as a central strategy. So have a look at the games, but I want you to reflect on your own learning. I want you to reflect on the idea that in this semester you actually learned so much about data structures and algorithms that you created an array of stacks and you sorted out this algorithm in your mind to create this game. Congratulations on that. I think you should feel empowered after this project. Hope you had lots of fun and good luck with this final assignment, but it's not the end of your Watersort journey. I'm sure you are going to spend a holiday playing with your program. That's my aim. Enjoy.